Other questions? So let's propose a cliffhanger here. Suppose that the functionality I want to implement next is when I type in something like DAVID and click go, I like the keyboard going away. I like the message then coming up. What I don't like now, anal as I'm feeling here, is that when I click thanks, I don't get the keyboard back. It still says David. This is really kind of a sloppy application. I'd really like focus to be given back to the text field. I want to see the placeholder text again, and I want my cursor flashing there for the next round of this game. So in other words, we need now, per your comment a moment ago, we need some way of having the dismissal of that alert view window signal to my code to do those cleanup steps. Give me the keyboard back, give me focus back, delete David, and start anew. But let's go ahead and take our second 5-minute break here, and we'll come back and solve that problem. All right, I know it's late, but we're almost there, and this next stuff will be amazing. But it will make you better at this. All right, so we are back. So where did we just leave off? So we have an implementation of view controller now in both our H file and our M file that does relatively little. In the H file, we have a property to that text field. Notice we don't have a property to the go button. Why don't we need a property to the go button? It's not an IB outlet, and we don't really need anything. We don't need to pull anything from it. It, in a sense, is going to push information to us when it's clicked. So we don't need a property for that. And if I look now at my M file, notice that all I've implemented is that IB action. And that IB action is called go, and it just does all that UI alert view stuff. But what we don't yet have is the ability to detect when the user dismisses that UI alert view button labeled thanks. As an aside, IB action and IB outlet, what are these things? Turns out it's just a very clever typedef. Typedef is a way of declaring a synonym in C, in Objective-C, whereby you can give a new name to a data type. And so IB action is actually literally a synonym for void. And void means a non-existent return type. It doesn't return an actual value. So all Apple has done is they have declared that IB outlet and IB action are synonyms for void. So the effect of this is to have no functional impact on your code. The compiler doesn't care. But what Xcode does is it uses regular expressions, essentially, skims your code, and anywhere it sees an IB action, it realizes that it can put this cute little circle here, and it can put that name, go, into the little drop-down menu. Same thing in the H file for the IB outlet. This, too, is just, this actually isn't void. This is quote, unquote. So literally, it's a synonym for nothing. So if the compiler gets rid of that, it has no functional effect, but it does know to put the little cute circle and to put the text field in the drop-down that we saw when I was dragging and dropping the blue line. So it's kind of a clever hack, if you will, to make the interface builder work without having to fundamentally change the language. All right, so let's now wire together the thanks button with our code in a way that allows us to round off the last of the technical topics from the very start of lecture. So we looked at categories briefly. Let's lastly look at protocols. I'm going to go into some of the prefabbed code from tonight into a file called nib2 so that we don't have to rewrite all of that code again. nib2, I'll tell you up front, is almost identical to the previous example, except that in advance I have solved this problem of wiring the thanks button up with my actual code. So let's look at viewcontroller.h. Do you see anything different in this file? What's different? Yeah. Exactly. So we have UI alert view delegate, which wasn't there before. In the previous example, nib1, this file was almost the same, but that was absent. So the fact that I have UI alert view delegate in angled brackets just means that my class, view controller, that descends from UI view controller is also going to implement some methods declared in that protocol. Now, I forget what they're called, but this is easily solved. Let me hold down Option, click on UI alert view delegate, click on the reference, bring up the documentation. And if I read this closely, you'll notice that if you add your own button, not that one. What do I want here? Scroll down. This one. Alert view did dismiss with button index. That is apparently, if I read the documentation closely, That is the method that will be called when the user did dismiss with a button index of 0, in the default case, that thanks button. So I just have to implement that now to be able to detect with an event listener that the button's been pressed. So let me go into my M file and see how I've done this. So what did I do here? Interesting. So alert view did dismiss with button index. What did I decide to do? So my comment is kind of spoiling the fun here. But when that UI alert view sends this message to my view controller object, I'm executing one line of code, which apparently does what? Clears the text field. How do I do that? I can simply set the property called text that's associated with my text field to nil, quote unquote, effectively. Setting it to nil is because of the setter, it knows to set it effectively to quote unquote. So that's how I clear it, so that I see the placeholder text again, not DAVID. And then lastly, this, actually, I did not mean to leave this in the distribution code. This was me tinkering around before. I will remove this. If I leave that in there, as soon as the alert view comes up, it goes away, because I was experimenting with a different example. All right, I'll fix that on the online source code eventually. So there's one other difference between this file and the last one, but it's a little subtle. What else have I done that's different? Yeah. Yeah, excellent. So whereas last time the value of delegate was nil, this time it's self. So this is a very common paradigm in iOS, whereby when you call a method on some other object, in this case the object in question is this UI alert view object, and you want to inform that guy to whom he should send a message when he's done doing something, you can pass in a delegate reference, a pointer to some other object. In this case, who do I want to be informed when that button is clicked? Myself. And literally, I pass in, therefore, self. Now, this works because the UI alert view object knows to send the message called alert view did dismiss with index to its delegate. If it's nil, no big deal. It's going to send the message into a black hole, so no one hears that message. But if I'm telling it that I am your delegate, let me know when you're done being clicked on, send me a message, I just have to pass in self. And because I have implemented this method now, I can hear it. If I get rid of that, the message might still be sent to me, but it's just going to go into a black hole as well. But here I've intercepted it, much like registering an event listener with JavaScript or jQuery in the most recent project. Yeah?
I wonder who's holding the pointer to the alert when the method's done.
Who's holding a pointer to the alert when the... so we have in this line here, so this is where automatic reference counting comes into play. So we have here an allocation of the UI alert view object. We have a pointer here. We're then sending the message. Essentially, what is happening here is the operating system is going to keep track of who still has a pointer to that object. And because this is the only guy in existence that has a pointer to that object, effectively when it goes out of scope, it will be reclaimed when it's no longer in reuse. And let me wave my hand at the memory management details for now, because we'll come back to this in particular next week, especially the notion of weak and strong as it might relate to something like this, where you're passing a pointer from yourself to some other object. But this is some of the magic that now happens underneath the hood because of that feature arc. Previously, we would have had to free it eventually ourselves. Technically, there's an auto-release pool that does this for us and automatically frees the memory eventually. All right, so let's take this up one more notch. I'm going to kind of whiz through this code just so that you don't feel that you're entirely dependent on this interface builder. Let me open up nonib.xcode project. And in this example, if I expand the files over here, notice that we again have main.m. And let me emphasize here, when in doubt, when reading someone's code for the first time, certainly lecture examples and even Apple's or others, I think it's helpful to start with main.m just to reassure yourself, okay, familiar, nothing there. Let me now follow the breadcrumbs and go to appdelegate. Okay, now I'm going to go to appdelegate.h. Nothing new here. This looks like the example from a while ago. View controller pointer and a window pointer. Appdelegate.m. No, nothing interesting in here. Looks like the brains of the operation are indeed in the view controller. Let's look at the .h. Okay, little interesting here. Alert view did dismiss with button index, go. Okay, that's actually the same as before. Notice I'm being explicit, as someone asked earlier, with read-write, even though that's the default. I could say read-only. ViewController.m. So here's the difference. And you can immediately see why I used Interface Builder at first. This is the code with which I've implemented things without a nib. Notice missing at top left is ViewController.nib. So I'm doing it sort of the real way, like without using a little drag and drop WYSIWYG tool. So the price you pay is that it's a pain in the ass. And so here's the number of lines of code I've written. And this is a bit of an exaggeration because I could have relied on some default